Hey everyone, welcome to the last section of stoichiometry. We are going to be talking about percent yield, and hopefully you will learn to calculate the actual yield as a percentage of theoretical yield. So the equation to calculate for percent yield is the actual divided by theoretical, let's put that in parentheses, times 100, because we want a percent. Remember percents, percenty, that's out of every 100. So your actual yield is the number through experimentation. So it's what you produced in lab. Theoretical yield is the number through stoichiometric calculation, and it's what you expect to produce. Had everything gone right, you don't lose anything, that's what you should have been able to do. Of course, we're not all super perfect, so your actual yield might be different. Looking at this chemical equation, we have two hydrogen molecules reacting with one molecule of carbon monoxide to produce one molecule of methanol. Calculate the theoretical yield of methanol when 68.5 kilograms of CO is reacted with 8.60 kilograms of hydrogen. You're going to begin with your 68.5 kilograms of CO. You have to convert this to grams first in order to get to moles to use the molar ratio. So 1 kilogram of CO is 1,000 regular grams of CO. And now we can do the molar mass. I'll draw my wonderful line. I know grams of CO will be at the bottom and 1 mole of CO will be at the top because I'm going to grab numbers off of the periodic table and those are all in 1 mole. So carbon is 12.01. There's only one of them. And oxygen is 16.00. There's only one of those. When we add those all together, we'll get 28.01 grams per mole. That means for every 1 mole, it is 28.01 grams. So that's the molar mass of methanol. Now that we are in moles, draw my wonderful line. I know moles of CO will be here at the bottom. I'm trying to figure out moles of methanol because that's how much we are trying to calculate for. These will be from the balanced equation. Since there's no number, it's an invisible 1, so both of these are 1. And the theoretical yield means I need to know the grams. So 1 mole of methanol will be at the bottom, since methanol was there at the top, right there, right? Just like moles of carbon monoxide and grams of carbon monoxide were there, and kilograms. So to calculate the molar mass of CH3OH, I have carbon, which is 12.01. There's only one of those. Hydrogen's mass is 1.01. There's 4 of those. And oxygen is 16.00, and there's one of those. When I add all of those together, I'll get 32.05 grams per mole. So I'll put my 32.05 grams of CH3OH at the top. To make sure all of this cancels, I have to look at what's at the top and what's at the bottom. Kilograms of CO, grams of CO, moles of CO, moles of CH3OH, and that leaves me in grams. When I put this onto the calculator, I'll get an answer that looks something like this: 78,380.04284 grams of methanol. If I rounded to a whole number without the decimals, it would look something like this. And if we wanted to do sig figs, this is 3 sig figs. So it'd be 78400 grams of methanol, because that 8 will round up that 3. Now you think you're done, but unfortunately you're not, because we have to do the same with hydrogen. So 8.60 kg of hydrogen. Same steps, we have to convert from kilograms of hydrogen to regular grams of hydrogen. Draw my line because I'm going to do the molar ratio. I know grams of hydrogen will be at the bottom, 1 mole is at the top. And for hydrogen, it's 1.01 times 2, which is 2.02 grams per mole. So 2.02 is here at the bottom. Now I can put in my molar ratio. 2 moles of H2 at the bottom. 1 mole of methanol is at the top. Fortunately, we already did the math for the molar mass. So 1 mole of CH3OH and 32.05 grams of CH3OH is at the top. That 3 does not look very good. So let me erase it and redraw it for you. To make sure everything cancels, let's pretend this is over 1. Kilograms of hydrogen, grams of hydrogen, moles of methanol, leaving us with grams of methanol. Put that all into the calculator, you'll probably get something like 68,225.24752 grams of methanol. If you wanted to just round to a whole number, 68,225. For doing sig figs, 68,200 grams of methanol. Now, we did both of these, but you don't really know which one's your theoretical yield. So you have to look at these numbers, right? You have to look at 78,400 versus 68,200. The least amount will be your theoretical yield because that's all you can make. So this, your 68,200 grams of methanol, is your theoretical yield. So I would say this is your TY, your theoretical yield. That's all you can make. From that, we can get your limiting reactant, which is right over here. I'll do it in pink. Your hydrogen is your limiting reactant because this, LR, this produced the least amount of methanol, which means your carbon monoxide is your excess reactant. And that we could say is your ER. So now how do we pull this all together for your percent yield? If 3.37 times 10 to the 4th grams are actually produced, what is the percent yield? Remember, percent yield is going to be your actual yield divided by your theoretical yield, and then times 100 because we want a percentage. So this is your actual yield, which is your AY, and we calculated our theoretical yield from the previous problem. So we are going to put your 3.37 times 10 to the 4th grams divided by 68,225 grams times 100 equals 49.4% yield. So if your actual yield was 3.37 times 10 to the 4th grams, and your theoretical yield was supposed to be 68,225, you had a 49.4% yield. Is this good? Well, it means you lost about 50% of your product. The 3 parts to the percent yield equation are your actual yield, theoretical yield, and the actual percent yield itself. If you are given 2 out of 3 variables, you can manipulate the equation to solve for the missing one. A lot of your homework problem is problems like that. If you have any problems, please send me an email, but good luck.